So can we start? Stomba. Alright, so good afternoon, ladies and gentlemen. We'll record this one so that now at our depot they'll benefit. Alright, so we're going to do these three questions on the board. We have the first one, which is asking us to prove that the Cosh inverse of x is equals to the log of x plus the root of x squared minus 1. That is the first question we're doing. Then from there we will evaluate the tan of 2 pi squared z dz in the region z modulus is equals to pi. And lastly, we're going to show that the modulus of z minus 1 is less than or equal to the modulus of z minus the modulus of 2. So this one is called the reverse triangular inequality. Right? The triangular inequality is where you have positives here. So, but for the reverse one, this is also true. Okay. All right. So we start with the first one. So someone to lead me. What are we proving? Cosh inverse of x is equals to what?
Is equal to log
Mm-hmm.
in the brackets x plus the root of x squared minus 1.
Alright, so which side do you think is much easier to start with?
Cosh inverse of x.
Rambi? Why the Cosh inverse of x?
Just to know Cosh x.
Which side do you think would be easy to start with? And explain why, Mr. Man. Alright, so as you see, when proving, you just start with the area that has more detail. You start with the area that has what? More detail. So here, we are going to start with the, which side? This is the right hand side. Right hand side, we let Z, or you can choose any letter of your choice. Which letter should we choose? Apart from Z, so that we don't confuse it with that Z. Which letter should we choose? We let A equal to the log of x plus the root of x squared minus 1. One thing I was able to observe from this part as I was doing the work with you is that this part is coming from a circle. Are we following? This part is coming from what? From a circle, in the sense that x squared plus y squared is equals to 1. Okay? It's coming from a circle with a radius 1. Okay? So we take note that the radius is equals to 1. But how does this change from this to there? Okay, this changes from this to there because we can multiply throughout by negative, so that we have negative x squared minus y squared is equals to negative 1. When we make y the subject of the formula, then what are we going to have? Negative y squared is equals to x squared minus 1, which is this part that is here. Are you seeing that? So simply we can replace, wherever there is this, we can replace with that. So meaning that our A will be equal to the log of x plus the root of negative y squared. Are we following? Okay, keep in mind that the radius is equals to what? To 1. Keep in mind on that. So now here, what is this equal to? What will this be equal to? What will this be equal to? When we simplify, what are we going to be? What will that be equal to? Mr. Moini.
Why?
Sorry? Yala Washan?
That's minus 1.
Why? Why would it be
Yeah,
like?
look at the square root of that.
To be root of negative 1 times root of y squared. So this can be separated into this part. What is root of negative 1? What is root of? Active push around. Unaangalia for 17 hours at Tindo, kurekesha apparat to share of work. Then when we simplify this to be y. Are we seeing how it has simplified to this? Okay. Now we have a simpler term. So, but x plus iy, so let me use a different color, but x plus iy, in polar form, what is it equal to? In polar form.
But we've separated this to right. Negative 1 is okay, 1 is okay.
Now we should have Upper? You know where this is coming from? From this. This can be written as negative 1 times the root of y squared, which can be written as the root of negative 1 times root of y. When you simplify this, this is I, which is this, and this simplified, which is y. Now, what is this in polar form? X plus iy. Oh, we know it's equals to z, but in polar form, what is it equal to? R e to the I theta. Okay? R e to the I theta. But remember that our R is equal to what?
It's equal to 1.
Is equals to 1. So this will just be equals to 1 times e to the I theta. So we can replace this here. Okay? So meaning that our A is equals to the log of e to the I theta, of which you can drop the powers. I forgot to mention this is log to base e, so you drop the power. This is I theta log of e, which will just be equal to what? Which is I theta. Okay, so this is log to base e. Log to base e of e is just 1 times this, just be I theta. So in simple terms, A is equals to I theta. Are we following? But what is x equal to in polar form? What is x equal to in polar form? What is x equal to in polar form?
Is it going to be cos x?
Bambi.
Cos theta. R cos theta.
R cos theta, very good. This is x in polar form, and y in polar form is equals to what? R sin theta. So you should take note of this, but we're not using this this part. We're just interested in this part. And why we are interested in this part is because in our question there is an x. If you remember, if we check back our question, pari x apanamona, that's why we've gone with the x. If there was y, we would have gone with the y part. Okay, so now we're only interested in the x. So now, what is our r equal to in this case? What did we say our r is equal to? So this is just equal to what? 1 times cos theta. Meaning that x is just equal to what? Cos theta in this case. So making theta subject to the formula here, what are we going to have? Theta will be equal to cos inverse of x. So we're going to get this and replace here. So meaning that our a will be equal to what?
Apply cos inverse of x.
Cos inverse of x. Okay? I cos inverse of x. Now we multiply both sides by I and I. What are we going to have on this side? When we multiply by I and I, what are we going to have?
IA
Negative IA is equals to cos inverse of x. This will have a negative when you multiply by I. So times the negative, so it will be this side. So we make x subject. So we're going to have x is equals to what? X will be equal to we make to be cos negative IA. This is what it will be equal to. Meaning that this, when you want to find this, you say cos inverse of that. So now the reverse of this, which is this. Then you say but cos I. Okay, let's just say cos z. What is cos z equal to? In polar form, those polar forms that we know, the equations is what? So this now can be replaced, or we can use this. We can use this for this. So we're going to say x will be equal to what? So if we use on this, if we use this definition on this, then x will be equal to what? Okay, this whole thing is z, so we're just replacing the z here, then plus e negative I, then negative I all over 2. Are we following? So when we simplify, what are we getting when we simplify?
There we have e to the power a.
E to the power a. Now what is this equal to?
It is Cosh.
Cosh over here. So which is equal to Cosh A. Okay. Meaning that x is finally equal to what? Cosh A. Okay. Now remember where we started. Where we started, we let A to be equal to this I. We let A to be equal to this I. Meaning that A is this. Are you seeing that? We let A equal to this, meaning that A is also equal to what? To that. So we need to make A subject of a formula. So making A subject of a formula, what are we going to have?
We're going to have A is equal to Cosh
Cosh inverse.
Cosh
X. Then you say, but A is equals to the log of X plus root of x squared minus 1. Okay? Then you can say, therefore, log of X plus root of x squared minus 1 is equals to the Cosh inverse of x. So that is how you prove. So these are elementary functions.
You know, it's a limitation. Limitation.
Sorry? It should be tutorial in our tutorial. Should be 3, I'm not sure. Should be tutorial 3. Okay, so but simply where we started is here. We let A equal to this part where we are starting, which is the left hand side. Then we recognize that this must have come from a circle with radius 1. But the only difference is that they had multiplied throughout by negative, which had not changed the meaning of the circle. Then we made this part the subject, which is this, which gave us this, which is the inside of that. So when we replace this here, we're going to have that. But we need to keep in mind that the circle where we're coming from has the radius 1. Okay? Then simplifying this gave us this.
Where's the radius coming from?
Sorry?
inside the square.
Radius? Radius? Radius left Marquis. Where is the radius coming from?
Inside the square. Where are the x squared minus 1?
This is, we are looking at this. Then we say this must have come from this. Okay? This must have come from this, and we've shown how it could have come from this. Means it was this, then they multiplied throughout by negative. Okay? When they multiplied throughout by negative, then they transposed the x, which is this part, then minus this, which is this. So this simply is equals to that. If here there was a 2, we would have used the same procedure, meaning that our radius would be 2, which is root of 2. Yeah. So root of 2 would be our radius. If this was 4, then that our radius would be 4. Okay? Then we simplified it to this. Then here we just started simplifying now. This is equals to z, which is just in polar form r e to the I theta, but r is 1. We replace, so we change where there is x plus iy, we put this, which gave us this. So we're saying a is equals to this, and we use log properties. The power can be dropped, then you remain log of the base. Then log of e to base e is just 1, so meaning that you're going to remain with I theta. So meaning that a is equals to I theta. Then we are moving with the goal. We know that x is equals to r cos theta. Our goal is to have cosh, so we have an idea that cosh can come from cos. So we say x is equals to r cos theta. Here we said r is 1, so meaning that x is equals to that. We made theta subject, which gave us this. Then we replace here, meaning that we're going to have this. Then after simple algebra, just simplification. Could I have made so that I can understand this?